at y equals 0. Or sorry, yes, at y equals 0. Okay? Now, in terms of what kind of extrema, if the derivative is 0, what's going on there graphically? Flat horizontal tangent, and if the derivative is undefined, what's going on there? It's a vertical tangent. So in terms of extrema of, now this actually does indicate an extrema of x, but we're not going to go there. We're going to focus on extrema of y, all right? Extreme y values. So we'll only focus on this guy. This is where a curve, like a circle, goes vertical, is in a fashion a relative extrema, but that's more for a differential equation A, not for Calc 1. All right. Now, let's talk about testing for extrema. When you use the first derivative test, you usually test intervals for where the derivative is positive, yeah? You with me? Or y? Okay, here. Y. I don't want you to get confused on that. Okay, are you with me? Or y prime changes sign. Sorry. So, here's y prime. Y prime is right there. Now, where could it change signs around? I'm hoping you'll kind of see something funny going on here in this case. It could change signs around x of -2, but also y of 0. Now, that makes for a two-dimensional sign test, which is not a thing. You don't actually do well, here's x against -2, and here's y. That's not something. You don't do that. Okay? So, if the first derivative depends on x and y, then a sign test is out. And you must instead use some kind of derivative test that works with at the point rather than around the point. And what test works at the point? Second derivative test, okay? Use the second derivative test. This happens with differential equations. If you get a differential equation that depends on x and y, you want to use the second derivative for the extrema test, not the first derivative. So we're going to need the second derivative. Would you take the second derivative, showing that good technique? And let's get it right. Low, d high, x high, low, square plus 1, big y, plus x plus 2, x, okay, you agree with some kind of second derivative is, if your second derivative is equivalent to mine? -y plus x plus 2 times the first derivative over y squared. Yes? All right then. Let's go with the two candidates. We have a horizontal tangent at x equal -2. Now, can I put in x equal -2 here and find my second derivative? No, I also need y. You need y also. How do I find y? Yeah, plug into the original equation. It was -2 into the original. So something like 4 minus 8 plus y squared equals 0, which means y squared is 4. So for that point, you're actually getting 2 points. Y could either be plus or minus 2. You have 2 possible extrema. Although x was only -2, there were 2 y's that go with that, so there are 2 possibilities. At x of -2, y of 2, or of x of negative 2, y of negative 2. You with me?
No.
Okay, which part did you get confused by?
No, there's like no interchange.
Sorry, do your best. Okay. Now then, the second derivative at negative 2, 2.
Why does it say y equals y?
Need y also.
Also. Okay. I'd go for an exchange.
Okay. So, negative 2, positive 2, it looks something like, you'll see it drop out and clean up pretty nicely. It's negative 2 plus, when negative 2 goes in for x, this whole ugliness goes 0. And y squared is 4. That tells me negative 1/2. Okay, so great. I have the second derivative at this point where it went horizontal. So what? So it's a max. Why is there a max there? Because the second derivative is negative combined with the flat, I'm getting a max. So let's say it well. The curve, I wouldn't say y, I would say the curve has a relative max at the point negative 2, 2, because I'm just going to use y prime and y double. Because why? There's two reasons for a second derivative test you need to cite. Because y prime is 0, it went flat there, and y double is negative there. Okay? Don't add in extra stuff you don't need to. Don't say y double is negative concave up, or y double is 0 horizontal tangent. All that stuff will lose you points. You said too much, because you are not making clear. If I say y double is 0 here, so concave up, what's concave up? The curve, the second derivative, the first derivative, minus 1. You just lost a point. You said stuff that didn't need to be said what needs to be said, and no more. That's all. Okay? So would you try negative 2, negative 2? Y double at negative 2, negative 2 is maybe 2 plus 0 over 4, which is 1/2.
Yes.
Therefore, the curve has a relative min. Has a relative min at the point negative 2, negative 2, because y prime is 0 and y double is positive there. All right. Now, I'll say this again. In cases when you're doing implicit and the derivative depends on y and x, you can use the second derivative test for your justification, not the first derivative test. You with me? I'll say that's a yes. Okay. Next, you will sometimes use the second derivative to talk shape of the graph, especially concavity and inflection points. Notice here that you're not being given the population equation, you're being given the differential equation for logistic growth. Those of you who are in AP Bio, this is kind of important, and it's something, whether you know it or not, that you study all the time. If you interject buddies into that field over there, for a while, how will the population grow? Exponentially. Do they grow exponentially forever?
No.
They don't. Why not?
Because the numbers are slight and it's also more hard to survive.
Okay, so biology people, what do you call that? There is a carrying capacity to the field. There is an upper limit on the population. Okay? Now, attaching your bio knowledge to your calculus knowledge, the equation for... Are you with me? Dude, I don't know, you guys just phone the hall if you want to jack around. Man, I don't need this. Okay? The equation for how the population grows over time looks like that. Now you can see this makes a little bit of sense. First of all, you never deal with negative populations. That's ridiculous. But as population approaches 40, dp dt approaches, as p goes to 40, this gets small, and therefore this whole thing gets small, and therefore the growth rate gets small. And so really, that 40 is the carrying capacity. As you approach 40 bunnies, the rate at which the population grows starts to tail off, and it starts to flatten out and just stay around that carrying capacity. All right. Now then, that's just side knowledge here. Given P is population, under what circumstances is population increasing? Now, we will assume P is positive. Now then, calculus-wise, big idea-wise, a function is increasing if population is increasing if what? Calculus-wise, you say something's increasing if its first derivative is positive. Okay, now looking at the first derivative, we know P is greater than 0. So this whole thing will be increasing, or the whole thing will be positive if what? Population is less than 40. Now it is possible that a researcher introduces 50 bunnies into that field, thinking that the field could support it. In that case, then, if 50 is more than the field could support, then at time 0 there would be 50, and the population would gradually decay until it started to approach what the field could support. And in that case, then you're talking decrease for P's greater than 40. That makes sense. If P is greater than 40, this is negative, and so you get a negative or a decrease. All right. Finding the inflection points on the curve, obviously that's where the second derivative comes in. Would you just in terms of P only? You can't find the time when that happens because we don't have the original equation. Would you answer that question for me, please? You might distribute first before you take derivatives, so you don't have to use the product rule. Make your life easy, right? Go ahead and answer C as well. They kind of go together anyway. So. For this problem, let's go with the assumption that it's that growing case. So let's assume also that P is less than 40. It's really not both curves, it's one or the other. So I don't want you to think you're on an inflection point at 40. It doesn't usually do Okay, so where's the inflection point? Inflection point if P equals what? Actually, sorry, let's not rush into it. Do you agree with my first derivative, 80 dp dt minus 4p dp dt? Okay. I played with mine a little. I factored out a dp dt and a 4, leaving me with 20 minus p inside, though you didn't have to do it that way. Then I substituted in for dp dt as we typically do with the original problem's dp dt. That left me really four factors, but three possible zeros, p of 0, p of 40, and p of 20, right? In terms of where we're interested in above 0 and less than 40, so I just focused on that interval and then sign tests, and I found positive before 20 and negative after. So, because the second derivative changed sign at 20, we would say there's an inflection point there, yeah? Inflection point at population equals 20 because p double changes sign there. Concave upward. If p is less than, if p is between 0 and 20, yeah? Because p double is positive. And concave down if population is between 20 and 40, because p double is negative. All right, I think there's one more thing I want to hit, but it's a big one. All right, last but not least, let's talk differential equations, applications that you might see on an AP question, AP test. Every year, there's one question that sticks in people's mind, or that's a gotcha, that was a mother. Last year, when people left the room, everybody was saying, "What'd you do for the potato problem? What was with the potato problem?" And people went home and Googled, "Hey, how about the potato problem?" and all that stuff. You're not supposed to really talk about it for 24 hours after. But this was the gotcha, or the you had to think kind of question last year on last year's exam. So it goes something like this. At time equals 0, a boiled potato is taken from a pot on the stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time 0, and the internal temperature of the potato is greater than 27 degrees for all time, positive time. The internal temperature of the potato at time t minutes can be modeled by the function that satisfies the differential equation dh dt is negative 1/4 h minus 27, where h is measured in degrees Celsius and h of 0 is 91 degrees. Now, just for understanding purposes, the graph is not necessary, but in terms of thoroughly understanding this, let's look at it. What's the dependent and independent variable I would put in the graph? Independent is time in minutes, and the dependent is the temperature of the potato in degrees Celsius. Okay? Give me a point on the graph. You know, 1 point on the graph. What is it? 0.91. Okay? What happens as time goes on?
It goes down.
It decreases. It decreases towards what?
27.
27. And what's special about 27 in the context of the problem, you remember? Yeah, what is it? It's the temperature of the room. Yeah, it's probably the potato gradually cools towards the temperature of the room. This is Newton's law of cooling. You guys studied Newton's law of cooling? Well, this is Newton's law of cooling. It's the third most famous differential equation there is. When does the potato cool the fastest? In the beginning. The picture obviously verifies that, but tell me in the differential equation how you know that to be true.
Because when h is big, it's more negative.
Yeah, when h is big, the rate of change is a greater negative, meaning the decrease is the greatest. So it's decreasing fastest early, and as h approaches 27, then the rate of change starts to go smaller and smaller, and so flatten out, yay? Are you with me? Okay then. So, be careful, I beg you, be careful. The differential equation is dependent on h, not t. That's a bit of a source of error. People will put time in when they meant to put in h and vice versa. You need to be very careful. All right. So the problem then started with something like this. Write an equation for the tangent line to the graph at time 0. Use this equation to approximate the internal temperature of the potato at time 3. So, I would hope you would say, all right, this problem's kind of kooking me out, but let me look for something I can do. It's kind of like an Easter egg hunt. You kind of got to look, but there's points in there that are gimmies. They're saying, find the equation of the tangent. And you should say, well, shoot, I can write an equation for a tangent line. What do you need for a tangent line equation? A point and a slope, and then you use point slope. So, what's the point? And you might get in your head, clear in your head, what's x, what's y, and that's temperature. Sorry, time and temperature, right? So give me a point. 0 times 0, the temperature is 91. The slope, you need to show to the person reading this, hey, I understand that slope comes from the derivative at that point, 0.91. Find the slope. This goes to be careful what to put in. Do you put in 0 or do you put in 91? You should be putting in 91. So what'd you get? So that would be 64 over 4, so I'm feeling negative 16. Yes? This was no calculator, by the way. Okay, so write me your tangent line equation, please. Go ahead and do that, and then use it to estimate. Do the second, or do the finish of the tangent line, then use it for the second part to approximate. What did you get for an answer, or an estimate? 43 degrees Celsius, right? Okay, now let's go on to the second part. There's the tangent line is your one answer, and there's your estimate. Yes?
Should you include squiggly equal signs anywhere in this?
Oh, you're right. You should say h of 3 is an approximation. Thank you. H of 3 is approximately. You're right. That's not truly the temperature. It's an estimate. Now, towards that end, could lead into the next part. Use the second derivative to determine whether your answer is an underestimate or an over an estimate of the internal temperature. Now, again, you don't have to 100% know everything in the question to get some points. You might not know, what do you mean, use the second derivative to see if it's an over and under an estimate. Even if you're not sure what they're getting at, you can still find the second derivative and get some points there, and then maybe as it'll occur to you how to use it. So would you find the second derivative, please? Okay, so I got 1/16 h minus 27. How about you? Remember, you take the derivative of h, which is dh dt, and then sub in for dh dt. So if you had, I guarantee you that at least half the people would have said dh dt, the second derivative is negative 1/4. Guaranteed. Now, what did they take the derivative with respect to? They took the derivative of h with respect to h. That is not what the question said. It said take the derivative of h with respect to t. And so if I take the derivative of h with respect to t, I pick up a dh dt. And then you have to sub in for that. All right. Now then, let's get into the rest of it. How does the second derivative help me tell if a tangent line over or underestimates? This is where the picture does help. Here's a tangent line here, right? At 3, Will the tangent line over or underestimate? Underestimate because the curve is concave up. Now you actually have to justify why you say it's concave up. Is this, if it's concave up, that implies the second derivative has to be positive. Is that always positive? Read carefully. See that? The temperature of the potato is always greater than 27. So you'd say something like, because H is greater than 27, and that's given, the second derivative is always positive, yeah? Now if the second derivative is always positive, the curve, that's probably enough, but let's go with concavity. Therefore the curve is concave up. So the tangent line will underestimate the true value. You follow? Okay. Last but not least, for T less than 10, an alternate model for the internal temperature of the potato. Actually, you could probably, should we go to the, let me just let you do this for homework, and should we go on to questions on last night? Okay, I'll let you do that on your own. That, if you go about it the right way, that should look familiar, that shouldn't be bad. Okay, so make sure you finish that. Oops, my bad. The homework from last night. Let me throw answers at you, and then we'll go back and do questions if you have them and if you have time. Are you ready? Yes. Yep. Oh yeah, that was my writing. That's
Well, I feel
optional.
like sometimes you write things and then you forget about them and you're like, oh, yikes. And
Oh.
then it's like a mad rush.
No, I meant that. Okay. So, I should include directions on this, whether you match the letter to the equation or the equation to the slope, but either way, the graph of this would have been C, D, A, B. Nope, this is a B rather, sorry.
Oh man, I had it right.
Sorry, C, I couldn't read my own B. I went lowercase b for some
I'm
reason.
writing it
Okay.
down.
On all of these, signs in the quadrants were a great way to go because all of these involve products. Quadrant signs are a great way to distinguish. If you went the other way, then this is more like 12, 11, 10, 13. Okay. The next page, if you matched to the graph, then it's E, C, F, H, G, A, D, B. If you match to the equation, it was more like graph 6, 8, 2, 7, 1, 3, 5, 4. You didn't have to match both ways, just as long as you have one or the other. I should have specified. Okay, you with me?
Be like on the test tomorrow.
Yes. Okay. This, I will come back and do the whole proof, but I'll just say if you had a delta of 20 epsilon, you probably were doing things correctly. This, if you had a delta of epsilon, linear usually goes fine, so that's not okay. I'll come back to that if you have time. This is e to the 6th. This is 2/3. That was a little ugly, that substitution. As a fallback, remember, you could do this by substitution, but you could also do it by L'Hopital. It is indeterminate. It does go 0 over 0, so L'Hopital does work. Okay. The antiderivative page, facilities or recall. You didn't have to show work in some cases. I was fine if you just recall them. You might have some things to study here if you don't know these right now. For example, the natural log of secant plus tangent is the first answer, plus c. Tangent of x is natural log of the absolute value of secant, although I would definitely take negative natural log of cosine. Remember, that's like using sine over cosine and then u subbing it. Natural log of sine, absolute value plus c, again, that's cosine over sine and u subbing it. And this is natural log of cosecant minus cotangent. Secant squared, you should recognize that derivative. That is the derivative of tangent. Cotangent squared is not a derivative, so you would use an identity. That's also something you might study. The identity for cotangent is cosecant squared minus 1. That then is a clean derivative, or almost. That's the derivative of negative cotangent, and that's the derivative of negative x. Okay? Tangent secant squared, I just straight up u sub this. I let u equal tangent. And so therefore, secant squared is my du. It becomes an antiderivative of u squared. So it's 1/3 tangent cubed plus c. It doesn't. Okay? Secant tangent, you should do by recognition. That is the derivative of secant. Cotangent cubed was probably the hardest. Cotangent squared cotangent. Cotangent then could be split into cosecant squared minus 1. Oops, cotangent. And then I did that by breaking it into pieces. Cosecant squared cotangent is u du. And cotangent is just by recall of above. Okay? And then this last one is integration by parts. This is your u, this is your dv. So by ultraviolet voodoo, it's x tangent of x minus log of secant of x plus c. You could also, I suppose, have plus log cosine. The differential question, it wasn't worded well at all. Estimate the area of the circle with if the radius is measured. What does that even mean? Estimate the area of the circle with if the radius is measured at 10 inches with a possible error of 1/8 inch. If you weren't quite sure what I was getting at, that's my fault. I apologize it's worded so badly, but this was my intention. Estimate the area of a circle if the radius is measured at 10 inches with a possible error of 1/8 inch. Now, we're going to have a base area, but then plus some possible error in that estimate. So the area could be something like the true area if r equals 10 plus or minus some error, yeah? Tomorrow the question will be worded more like this. So the true area is pi r squared at an r of 10, and the error can be estimated by dA. Or the true error is delta A, but the differential to estimate is dA. That's something like 100 pi is what the area should come out to be, but how much could it be off by? Well, dA then is A prime at the initial r times an amount of error, dO. That then is 100 pi plus or minus 2 pi r at an r of 10, and the dr, or how much the radius could change by, is positive or negative 1/8 of an inch. And therefore the area could be something like 100 pi plus or minus 20 pi over 8, or 5 pi over 2 square inches on either side. Okay? You with me? Okay. This is really what you should have been able to do. Relative error is the idea of comparing the differential estimate of the error to the thing you measured itself. So in this case, relative error in the area would be to compare dA to A. dA, now if you did all this work up here, then you didn't really need to redo it. dA is that guy, 5 pi over 2.
After, like, in the testimony, you have to write the equation of dA over A.
Yeah, so good question. If I said, so let's say, on the test tomorrow, the question might have been something like, the area of a circle is measured with the radius of 10 inches. And then it would just say, find the relative and percent error in the estimate of the area. In that case, then, you should find dA, and that's the first thing I would be grading for, is you explain where dA comes from. You find it, and then whether you find the A also as a piece, and then talk about the two pieces together, that's up to you. But this, if I don't see a differential in your work, and where the differential comes from, the derivative times the differential of these terms, you're not going to get much, because that's where all the points are. The answer is worth little. The work is worth the points are. Okay?
You have to do that if it's in another.
If it's in another, then you wouldn't need to do it. Yeah. Okay, so 5 pi over 2 to 100 pi is something like 5 pi over 200 is the relative error. So the percent error is, 5 over 200. The pi's drop out, don't they? Sorry, the percent error is 2.5. Okay. And last but not least, estimate the cube root of 7.4 using differentials. 7.4 is the cube root of 7.4. So the function is obviously the cube root, or x to the 1/3. I would start by getting the clue as to what is the function even going to be, and what's the good value it's like. What's the good value this is like? 8, okay? The big idea is y new is like y old
That made it interesting.
plus dy. So that should be your starting point, something like, in this case, the y new is the cube root of 7.4, y old is the cube root of 8, and dy is f prime at x initial dx, yeah? This should typically be maybe 5 points. So look at your work here. Did you have that? That was 2. It's hard to say use differentials if I don't see a differential in where you work. I can't tell you how many people start there. The best you're going to do is 3. You didn't show a differential. High 5. Okay? That is a differential. That is the question. All right, so that's 2 points. That's 2 points. So that's something like 2 plus 1/3 x to the negative 2/3 at an x of 8. And the dx is, how do we change as we go from 8 down to 7.4? That's a decrease of 6/10, 0.6 if you like. That's 2 plus 1/3. The cube, let's see, 8 to the negative 2/3. What is it? It's over 8 cube rooted, which is 2. Squared is 4. Okay, so that then obviously cleans up a lot. 2, a 12th, and the negative 6 divide away, and I feel something like 2 minus 1/20, or 1 and 19 for your answer. Okay.
And use 7 as the original value, and makes it a lot more interesting.
Yes, I imagine it does. All right. Anything else you'd like me to talk about, or talk about in more detail? Go back and talk about it. What? 4? 4. Where's 4? 4. Okay, here we go. So my scratch work that I left off, Do you want, or do you just want to see the proof? And the scratch work will kind of come into play once you see my work. So it goes like this. I will try and prove if x minus 3 is less than delta, then f of x minus 1/5 is less than epsilon. Even if you stink at this, that's an easy point to earn, because at the very least you know what you're trying to prove, the definition of a limit. Okay? So here goes. X minus 3 is less than delta, which implies x minus 3 is less than 20 epsilon. Here's where you have to explain where 20 epsilon comes from. You start with the assumption that x is close to what they say to get close to, which is between 2 and 4. Your goal, then, is to gradually build out. Now, this is where you would have been looking at your backwards work, which I need to look at. I know that if this is true, then if I add 2 to each piece, 4 is less than x plus 2, which is less than 6. Now, if I multiply both or each piece by 5, 5 times 4 is less than 5 times x plus 2 is less than 5 times 6. And if I then throw on a little cleanup, 20 is less than, I'm going to put absolute value on that, although it's not necessary because it's positive. I'll throw it on there anyway. No one can argue with that. And then I'm going to throw in an epsilon. 20 epsilon is less than 5 x plus 2 epsilon.
Good morning, Dudley Zachlau. Please rise for the Pledge of Allegiance. Buddy, begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students, don't forget Rob Brannon's presentation on
Okay, so if this is true, then x minus 3 is less than 20 epsilon. It must also be less than 5x plus 2 epsilon.
Are you looking for leadership positions next year and enjoy volunteering? Apply to become an interact officer. Applications are in mid-May.
It is less than 3 weeks away. The slam is back. Do you have your forms turned in? You can pick them up in the main office from Mrs. Natalia or register online. Don't miss out on volleyball tournament.
Democrats for Life of America Essay Scholarship is open to students aged 16 to 26, regardless of political affiliation or political position. The essay contest runs until
All right, now, this is where the split is harder to achieve.
Jefferson County Young Adult and
The reason you see the second one going x minus 5 plus 2.
Get your name out to multiple employers to re-register. Stop by the job opportunity board for additional information.
Help support those in need by donating
So I can take x plus 2 over negative 5 over.
Thank you for your support.
Senior high students,
This
juniors,
then becomes
morons,
1/5.
you will be taking up the SAT. We will have the normal school day and you will be attending.
Unfortunately, I need to switch the order, so I wait I can, because the absolute value is allowed.
You will be assigned a group and then begin the
And then I can
15-minute test. See Mr. Hawkins if you have any questions.
Seniors, if you have
That's
any
fine.
scholarship awards of any kind, please get
I have
them with a
nothing.
copy no later than Friday. If you know your destination for the next
You didn't do the scratch work on this paper, did you?
Catholic, and pay your transfer fee.
FBI Denver
If you got another paper, you shouldn't have
Learn
a
how
scratch work.
FBI agents discover absence in crime scene or conduct investigations. This is the Denver
I guess you could put a piece of paper over it and take it over. I don't know if there's anything else you'd like to know.
Rewrite the sophomore, junior, and senior. The Academy is June 13th or August 3rd from 8 to 5 p.m. Deadline May 7th, and counseling has the details.
Sadly, Zach, congratulations to the girls varsity tennis team for defeating Valor 5-2 yesterday. And I know to see your girls 17 happy grade. Their event was great.